during the sessions because there is a high probability of dropping of participants. Fortunately, today we have almost all. Okay, so let me present. Thank you so much. All right. So I'm now I will tell about the stepwise regression. Actually, in all the regression models, or we have applied two methods to remove the multicollinearity. Like method one, we calculated individual VIF, then dropping the items. In multiple regression with collinearity diagnostic also, we have to drop the items one by one. Suppose there are 15, 20 IDVs, 15 to 20 IDVs, and there are 4 to 5 having multicollinearity. Okay, then there will be a problem of it will take a lot of time and we will have many iterations. So the problem is to solve this problem, we have third method, that is stepwise multiple regression. Okay, now the stepwise multiple regression has a rule, has a formula, that it introduces the most important variable first. Okay, so it introduces the most important variable first, and then second most important, and so on, and excludes the insignificant variable. And why multicollinearity is one of the reasons that a variable is insignificant. I give you an example. Suppose you buy a book. Suppose there are 10 chapters in the syllabus. Okay, so a student wants to buy a book that covers all the 10 chapters. Now there is a book A. Book A covers 8 chapters of the syllabus. Book B of the same course covers 3 chapters of the syllabus, all that are covered by book A. Right? So these all 3 chapters are there in the book A also. So which book we will buy? Both books or only book A? So you will buy book A only. Why? Because book B is not contributing anything. Isn't it? Am I audible to all of you? Does it make sense?
Yes, sir.
Ah, book B is not contributing anything. So in Indian cricket team, yesterday I was counting, there are 5 wicket keepers. So they don't play together, but there are 5 wicket keepers. Right from Rishabh Pant, Sanju Samson, KL Rahul, Jitesh, and Ishan Kishan. So all 5 are good batters. All 5 are good wicket keepers. Can all 5 play in one team, one playing 11? Maybe 2020, maybe test, maybe one day. Can we include all 5 wicket keepers in one team? No, because we need only one wicket keeper. If another wicket keeper comes in the team, like maybe in yesterday's or day before yesterday's match, there were two wicket keepers playing, KL Rahul and Jitesh, but the other was playing for batting, not for the wicket keeping purpose. So if a variable is not contributing in the model, stepwise regression model will include it in the excluded variables. So it will be excluded from the main model. Applying it is very, very simple. This is our input file. We go to analyze, regression, linear. You can see here there is a method called enter. Enter, instead of enter, we will choose the method stepwise. So I'm taking a screenshot again and I'll paste this screenshot here. Okay. So what we'll do is we will choose the method stepwise and okay. Now you see in model summary there are one and two models. In ANOVA there are two models. In coefficient there are two models. In excluded variable there is one model, and this is collinearity diagnostic. So we are interested in first knowing why there are two models. If there are two models, means two significant variables. Okay, right. Two models means two significant variables. So it introduces one by one in the model. So first it introduces, you can see in the coefficient table, if I let me do something different this time. I'm just cutting off the coefficient table like this. Okay. You see, first vehicle weight is introduced. Vehicle weight is the most important variable. And it explains uh, its standardized coefficient is also quite high, which is again equal to the correlation coefficient, almost analogous with that. And it is significant, then it takes this into consideration, the horsepower. And then both of them have these values, the coefficient and all, and both are significant because the p-value is below 0.05. Okay, so dependent variable is miles per gallon and independent is 1 and 2. In first model there is only one, so we will refer, this is the final model. Okay, second is the final model, right? Now if we move forward, this is the list of excluded variables. Excluded variables written horsepower is excluded. Okay, no. This is excluded in the first model. Oh, this was excluded in the first model. The I think there is an issue in this. We have not included engine displacement. Right. Now this is the final model. So excluded in the second, excluded is engine displacement only, and this is the model 2 where two variables have been included. Okay. This is stepwise regression. All right. Any doubts? I think it has been a bit technical for all of you, isn't it? If anybody has any doubts, any issues, please let me know. Okay, fine. So let me come to the another part of the another way that regression is used. So far we were dealing with the data that is a ratio scale data. Now we will deal with the Likert or say interval scale data, in which we say Likert scale data. Suppose we deal with Likert scale data. Right. So in the Likert scale data, generally what happens, we make a scale, we make a measurement scale. I have given you a del data file. Okay, let me open that del data file here. Okay, so in this del data file, I have the statements from A to A11, and if I find it, this one. So, how many of you have heard about exploratory factor analysis, and any idea if you can share with me?
So exploratory factor analysis is a multivariate tool which is used to, um, let's say, for an example, if we have 100 to 200 factors which are affecting a variable,
Uh-huh.
if we want to shorten the number of factors, we use exploratory factor analysis.
Okay, fine. Anybody else?
So in this AFA, we try to reduce many variables to fewer one, and we actually try to cover out the latent variables which are not
Oh,
very clear.
good. So both of you are correct, and you have given a different dimension. So basically, we want to measure certain variable, which is a latent variable, and we measure it with the help of the manifest variables. One thing, and if it is an exploratory study, through thoroughly exploratory study from, and we have come out with certain variables and we have measured them. So to see that how do they, the unstructured pool of variables can be structured, we use the exploratory factor analysis, and there are many other uses. Okay, so in that way we consider that we avoid the multicollinearity also. So suppose I'm um, somewhere, I have a pool of say 10 variables, one to say 15 variables or 15 statements or items, and I want to see whether all these items are good for me, all these statements, so I can go for EFA, exploratory factor analysis, and eventually I found that these 15 can be clubbed in say four constructs or four factors, maybe two in some factor, three in some factor, four in some factor. Okay, so this is the way that this helps me automatically to remove the multicollinearity, because suppose factor one, statement one, two, three, four, these four loads on one factor. Okay, so this happens based on what? Correlation. Okay, this happens based on correlation. So highly correlated variables or items, they connect with each other, and correlation is the measure of multicollinearity also. Correlation is the basic of multicollinearity as well, right? So how do we do factor analysis? I'll not tell you that, but I will tell you that suppose you have done factor analysis. So, and what is the mechanism that helps us out, and how do we use regression after factor? Now once upon a time, when we talk about say Scopus publications, factor followed by regression was a popular method, okay, to publish in papers in good quality journals. Nowadays, structural equation modeling or smart PLS is also not a guarantee to publish, but once upon a time, I saw a few papers in Indian Journal of Finance, Finance India. Even in 2023, I published a paper. In 2023, I published a paper in um, a Scopus journal, Scopus Index journal in Inter Science, applying EFA and regression, multiple regression. Okay, so In fact, structural equation modeling is also a regression, but that is after confirmatory factor analysis. So we have additional advantage of discriminant validity check, model fit check, AVE, a stringent check on model fit and validity and reliability. So and that we can handle mediation moderation also. We can handle the multiple dependent variables also. Okay, so let us take an example. Suppose we have certain variables, suppose 11 statements. Okay, these 11 statements, these 11 statements are related to a questionnaire that is related to measuring the consumer innovativeness. Okay, so since I have already worked on, I will not show you the statements because that is not our main course of this session. So suppose we have three variables. One variable is consumer, uh, one variable is opinion leadership, and second variable is consumer innovativeness, and third variable is uh, opinion leadership for computer products. Okay, all right. So these were the three variables that I derived from that questionnaire based upon the 11 items. Now, if we apply factor analysis on this, right. So again, I repeat, I'm not teaching you factor analysis. This I'm doing it. So how to reach to regression part after doing a factor analysis. Okay. So here roughly it tells me that there are three factors derived from the 11 statements, and these are the composition of the factors. Right. So I'm interested into 11 thing only, not the extra stuff. So A1, A2, A3, A4 that loads on factor 1, A5, A6, A7, A8 loads on factor 2, and then factor 3. Now the important thing here is they're all because of the correlation between each other. So there is a high correlation in A1, A2, A3, A4. Similarly, 5, 6, 7, 8 high correlation, and 9, 10, 11 is high correlation. So they form this factor 1. This factor 1, A1, A2, A3, A4. Factor 2 is, that is component 2, A5, 6, 7, 8, and 9, 10, and 11. This is because of, I repeat, high correlation. Okay. So suppose if we don't apply factor analysis, the issue of multicollinearity will persist between A1, A2, A3, A4. After factor analysis, we don't use the manifest variables. We don't use these items for further analysis. Okay. Now suppose our component 1 is OL, opinion leadership. Component 2 is CI, consumer innovativeness. Component 3 is OLCP, opinion leadership for consumer products. Okay, fine. If you have any doubts, please ask. I will repeat the steps and process. Yeah, either it is all clear or it is all clear. Okay. Where are my active participants? Dr. Preeti, Udbhav, sorry.
Sir, at least this much is clear.
Yeah, good. Uh, Can you show the step once again? This is the most common question. Okay, I will. So what I have done is, see, I suppose I had an objective to measure consumer innovativeness. Okay. Now what I have done is consumer, say, opinion leadership for computer products, and I see that somebody who is an opinion leader for any product and who has a consumer innovativeness is probably a good opinion leader for the computer product. So I prepared a questionnaire, distributed the questionnaire, got the data collected. I had 11 statements in the questionnaire. Some were related to leadership, some were related to consumer innovativeness, and other few statements were related to the opinion leadership for consumer products. I applied factor analysis to measure my variables. So I got a structure like this. So I'm happy to see that it has been beautifully divided under these three uh, constructs. Okay. Now what I do is, again, I'm repeating the steps. I'm just okay. Right. So this is the way that we calculate. What were the steps? In extraction, sorry, in rotation, I have chosen Varimax from none to Varimax. Continue. In options, I just expressed the data zero point 0.5 so that my loadings are clear and I can clearly identify the factors, that under which factor which item goes under which factor. Okay. Now what is factor loading, what is communalities, what is eigenvalue, I cannot tell because this is entire part of the exploratory factor analysis. Right. Only 4 items are enough to measure particular factor. Even see now, in the era of smart PLS, only one item, even people use one item also. Okay. ठीक है, एक एक आइटम भी यूज करते हैं हम, बट 3 to 4 इनफ है, कोई ऐसा कोई क्वेश्चन मार्क नहीं है. इवन इफ यू आर वर्किंग इन एमओस, 3 is अ गुड नंबर. आई मीन 3 is अ मिनिमम गुड नंबर. 3 से कम नहीं होना चाहिए. ठीक है, अगर आप एमओस में काम कर रहे हैं. स्मार्ट पीएलएस में कितने पे भी कर सकते हैं. ठीक है. राइट. सो कमिंग टू दिस अगेन, अब क्या करें, व्हाट टू डू नाउ. सपोज अब नाउ द सिचुएशन इज क्लियर. You have 11 variables, items, okay, and you have 3 factors or components. I have a simple video on EFA. I can share with you the link where I have clarified latent variable, component, factor, cluster. Okay, so not cluster, factor, component, construct. Okay, the vocabulary of EFA. So I can share that later. Here it is not much required. Now suppose my hypothesis is HA1 OL influences the OLCP, or say positively influences the OLCP. HA2 is CI positively influences the OLCP. These are the two hypotheses. Now, how do I proceed further to prove them? This is called factor followed by regression. अब क्या करें बताइए. How should apply the regression analysis?
Like OLCP
Mm-hmm.
can be a dependent variable on OL.
That is a dependent variable, and CI is independent. OL is also independent. This is a simple, this is a multiple regression model. Okay. But how should I apply? I'm into this file. Can you guide me? How should I apply regression? Hmm?
So we should start with the first important variable that we have out of the three.
No, but how do we do it? We have 11 statements. Out of 11, 3 are of dependent. These are of one variable. These are of three variable, one variable, two variable, three.
So the problem with multiple regression is that we can use multiple independent variable but a single dependent variable.
Mm-hmm.
So
So
in this case,
Udbhav,
I would.
Udbhav,
Yes,
do
sir.
you want to suggest me that suppose if I have only one statement or item in the dependent variable, I can use all of them as an independent variable. Is it so?
Po- Possibly so.
No. Again, multicollinearity will be there. No? Then why we have
Okay.
applied factor analysis?
Yes, yes, yes.
No use of applying
Yes,
factor
sir.
analysis then, right? So
Hmm.
now this is one variable. Okay, let me tell you one very basic thing in SPSS also. This is one variable. This is another variable. Second, and this is the third one. So in SPSS and in any software, each variable is one column and each respondent is one row. Okay. So let us see, do we have one column for one variable? One column for OL and one column for OLCP. We don't have. So first we have to form that. We have to form one variable which represents one column that represents the four items. One column that represents item 5, 6, 7, 8, and one column that represents 9, 10, 11. So there should be three columns representing the three components, right? So there are three methods of doing it. Method number one, take the mean values. Mean values means A1 plus A2,
Say three plus.
okay, A2 plus A3 plus A4, okay, and divide by 4 for all the respondents. So there will be one column. One column means average of 5, 6, 6, 6, and here we can write the average. Average of 2, 2, 3, 2, here we can write the average. This method is recommended for mean based comparisons. Mean based comparisons means t-test, ANOVA. Okay, not for regression. Second method is method 2. Take the factor scores. Factor scores. Save factor scores while applying what? Factor analysis. Or I must be specific, exploratory factor analysis. Okay? This is method 2. What is method 3? Method 3 is imputed value. Take the imputed values. Okay? And imputed values we can take when we apply confirmatory factor analysis in MOS. फिर जब confirmatory लगाएंगे, when we reach to confirmatory, we will rather go for SEM. Why regression? वैसे तो both are same. But when we go to MOS, then we will do structural equation modeling. So this we are not doing right now. This is not recommended for regression. बचा क्या? Whatever left is method 2. We save the factor scores. But there is again a problem in the factor scores. First, let us save factor scores and then we'll get back. I'll get back. Okay. So what I do is in the factor analysis, while applying factor analysis with the rotation method of Varimax. Okay. This is the serious limitation of Varimax method. In this method, I'm doing what? I'm saving the scores. See, this is the saving the scores tab. Scores, save as variables, by default regression, continue, okay. Okay, so we are not looking anything in the output file. Let us go to our input file. 3 new columns will appear. Okay, and these 3 columns represent 3 factors subsequently, one by one, respectively 3 factors. Factor 1, factor 2, factor 3. Okay, so if we rename these 3 factors, say opinion leadership, CI and OLCP, going back to this, let us apply regression analysis, linear regression. What is our dependent variable? OLCP. Our independent variables, OL and CI. Okay. Okay. See the results. R square is 0. R square is 0. Adjust is minus. Significance is 1. T0, beta 0. Small standard error, nothing. Subs half. So method is wrong. Now what to do? This we cannot apply, this we should not apply, this we should not apply. Whatever we can apply is not giving us the results. Why it is not giving us the results? Right. Let me tell you. Varimax rotation in EFA. You will study it in detail in the tomorrow's class. I'm just telling you. Varimax rotation in EFA assumes that there is zero correlation among the factors, which is practically not true. Not true. And generally, in the stack of factors, we have both IDVs and DVs. So then, if we have both IDVs and DVs, and if you already assume that there is a zero correlation, it means there is zero impact of IDV on DV. How is it possible? So we should change our method. So we change our method to Promax. Okay. So change the method to why? But you can say that why I have not applied Promax in the beginning, because Varimax is the most popular method that people have been doing it for years and years. Okay. So I think I should delete this so that I can again rename and do. So now what I am doing is I take factor analysis again, and in the scores, sorry, in the extraction, sorry, rotation, in rotation I choose Promax rather than Varimax, kappa 4 by default, and continue and okay. Now all the results will remain same. The name of the matrix was component matrix. This is pattern matrix, structure matrix. So it doesn't matter. But in the input sheet, I again have 3 columns, 3 variables, naming them again opinion leadership, consumer innovativeness, and OLCP. Okay. And then applying multiple regression. Now see, there is some R square. R is 0.541, R square is 0.6264. Let me copy and paste. Okay. So, so two variables explain around 26% of the variation, R square and adjusted R square, 26% of the variation in the dependent variable. Okay. Whether they are significant, let us see again. One is significant. One is significant. Why these names are not coming? Let me correct. Go to variable view and delete this label and run the regression again. Yeah. So OL, opinion leadership, is significant. CI is not significant. Opinion leadership is, you see, this is significant. Why? Because the significance value is less than 0.05. CI, consumer innovatives, is not significant because the value is above 0.05. Okay. So this is the way we use multiple regression through uh, after factor analysis. I can just show you a small walkthrough of my paper. This is the paper, it's 2023, yes. This is the paper, Role of Artificial Intelligence in Knowledge Management, empirical study of industry experts using stepwise multiple regression. So in this, you see that in this I measured dependent variable as one single line only. So I applied factor analysis on this, and this was overall impact used as a single statement. Single statement variable also you can do. In the book of Naresh Malhotra, you will find a research on service quality. In that service quality also, dependent variable was measured as a single variable. So that reduces a lot of problem. But now there is no problem actually. If you know the method, you can measure it in this way also. Okay. So coming to this paper, this is the way that these are the denotions of the variables and all, right? So beta 1 x1, beta 2 x2, this is the multiple regression equation. Dependent, constant, parameters to be estimated, demographic. Then these are the factor analysis results. Four factors were extracted from 20. These are factor loadings, factor names, right? And this is regression analysis, then followed by the factor analysis. So these are the four independent variables, results of four variables. We presented the results in a figure typographic form. This is a very simple paper. Now there are many journals that accept. Still, there are journals. If you have a new topic, novelty in your topic, you can apply factor and regression. They accept. Many journals, they accept papers on t-test and ANOVA also. If you have a rigor in the presentation, and such journals generally have number of words allowed, maybe 4,500, 4,000 or 5,000 words paper. If you want to publish in good Scopus journals, you need not go for structural equation modeling or smart PLS and all. Okay, but yes, the quality and rigor is very much required. The topic should be novel, and many others. So I think that's all from my side. I have, I think, covered the uh, many things. I will share this paper for sample purpose if you want. And there was, I think, in my collection, I will find that paper of Finance India also, where the factor score was used. Okay, fine. Any questions, anybody, before we wind up for the day? I'll be happy to answer your questions. Maybe they're not directly related to my session. If you have any question regarding publication, regarding anything, you just let me know. Yes, Mr. Chakrabarti, please.
Sir, these Dell data files, uh,
Yeah.
if you open the Dell data files, there are uh, A to K, 11 variables are there.
Hmm.
And there are how many questions there were, the data was collected for 360 odd, I think.
Yeah, 370 odd number, 372 or something,
And
372.
370, yes. Was what the Likert scale was followed.
Yeah, Likert scale was followed.
But
Yes.
because there are Likert scale normally gives you 1 to 5, but there are some values which are 7 and 6 and 7 and so on. So can you just explain how this
No, can you repeat your question?
actually Likert scale we measure from 1 to 5?
No, no, Likert scale can measure 1 to 7 also.
Okay.
It's not that Likert scale measures only 1 to. And see, let me tell you, it is not. I mean, it's an interval and Likert scale are sometimes not understood properly. Every interval scale is not a Likert scale.
Okay.
Okay.
Uh,
So, what is a Likert scale? This should be known to all of us, right?
so suppose I prepare a questionnaire and I give 5 options.
Mm-hmm.
So accordingly, I can put the values from 1 to 5.
Ah, you can do that. See, Likert scale means what Likert said. Likert said that ask one things in a similar way to the respondent again and again. Okay, that was the Likert scale. Likert does not mean a interval scale point, and that is okay. That also was there in the Likert scale, but that is all already there in all the interval scales. The speciality of Likert was that Likert said ask the same thing again and again in a similar way. Okay, not identical way. Okay,
Okay.
that was the Likert scale.
Thank you.
Okay,
Good evening, sir. This is Dr. Sunit from BIT Devghar.
Dr. Sunit. Okay, yes, sir. बताइए.
Yes. Actually, I have a question.
Hmm.
Suppose I have filled the questionnaire having 20 questions and the variables are not highly correlated. So can I
Mhm.
go directly to the regression analysis or still I have to do the factor analysis for the same?
You do the factor analysis once and see if there is any pattern. If you see there is no pattern, then that is not a, see, there is a difference of reflective and formative scale actually. So if you find correlation, that is a reflective scale.
Mhm.
If there is a correlation between items or statements and they form, they represent a factor, that is actually reflective scale. Okay, otherwise it is formative scale. So if yours is formative scale, you can directly apply that regression analysis. Okay.
Okay, thank you so much, sir.
Any other questions?
Sir, is there any book or like uh, any place from where we can have learn in detail these things? Because
Actually,
many
all
terminologies are there which we are not knowing.
actually, the best thing is Dr. Neeraj Kaushik's YouTube channel. Follow
Okay,
that,
sir.
Dr. Neeraj Kaushik. Okay, so
Okay,
you will learn everything from that channel because there are books. There is a book of Hair and Black. There is a book of Andy Field. These two are very good books. You can learn from these books also. But if you want to learn, because there is a book of Latin also, but nobody can understand it until and unless you don't have a very strong background of dealing with the multivariate statistics. So I would suggest go for videos, and especially Dr. Neeraj Kaushik's videos are all in Hindi and English mix, almost Hindi. Very comfortable, so you won't feel a fatigue while listening to his videos. You can listen,
okay,
you can learn from that.
okay. Thank you, sir.
Thank you. Anybody else? Any more questions? Okay, so Niket sir, can I shall I wind up for the day?
Yes, sir, it's entirely up to you. But
Thank you. I think now I would like to finish for the day. I have completed the topic. Okay. Thank you.
Thank you, sir. It was very enriching session.
Thank you, sir.
okay, okay. Would any participant like to thank the speaker of the day, Arun Mittal sir? Participants, would anybody like to come forward and on the camera and say thank you to the? Okay, Preeti ma'am. Thank you.
Thank you, sir. It was a very insightful session, and it has been a good learning. जो बहुत ही important था कि the way you have taught like writing, and so it has we have been always very alert mode what you are writing and what you are saying. So it was a good mode of teaching, and it was a very insightful and learning session for me. Thank you so much, sir.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you, participants. And thank you so much, Arun Mittal sir. Thank you, everyone. We will meet tomorrow with more interesting topic and next expert speaker. So see you tomorrow.
Thank you, Niket sir. Thank you so much, everybody, all the participants. Thank you.
Okay.
Thank you.
Thank you,
Thank you,
sir.
sir.
Bye, everyone.